Okay, so welcome back to the second part of Trig P.7 and Pre-Calc 1.6 notes. We left off in the part 1 video with discussing the increasing and decreasing portions of this graph. So remember, we're going to be looking at the x values. And notice that our farmost x value, the leftmost x value, is negative infinity. And what's happening is it's very close to the x-axis, but as it's moving this way, it's getting further and further away from the x-axis. So what we can say is that it is actually decreasing until it gets to 0. So from negative infinity to 0, it's decreasing, and at the same time, since it doesn't exist at 0, we jump back up here and say then at an x value that's really, really close to 0, it is continuously decreasing as well until it gets out to an x value of infinity. So we would say from 0 to infinity, it is decreasing as well. I can't just say that from negative infinity to infinity it is decreasing. The reason I can't write that is because my graph does not exist at 0. So I have to write the decreasing values as between negative infinity to 0 and then from 0 to infinity, okay? Because of the fact that my domain says that x does not exist at 0. And that's a common mistake that students will make. They'll say, oh, this graph is decreasing here, it's decreasing here, so it's constantly decreasing. That's not the case because the graph doesn't exist at one spot, particularly at an x value equal to 0. And so since this graph is never increasing, we'd write none there. Okay, the next concept that I want to take a look at is the step function. The step function, the notation for taking the step of something is this double bracket system that you see here. So we're really going to be graphing y equals the bracket or step of x. Now you can't input this into the calculator using the brackets. You actually have to use the int button in your calculator. I'm not going to actually have you do that quite yet because I want to show you what the graph looks like and then we'll verify it in the graphing calculator. So we'll get back to this in just a minute, but here's what the step function means. The step of x means the greatest integer less than or equal to x. So the greatest integer that is less than or equal to x. So basically what we're doing, for example, if I ask you to take the step of, let's say, 1.72, I know that 1.72 is between 1 and 2. So the greatest integer that is less than this number would be 1. On the other hand, if I ask you to take the step of negative 1.72, I know that this is between a negative 2 and a negative 1. So the greatest integer that is less than negative 1.72 would be negative 2. Okay, and that can be confusing because we look at this and we say, well, 2 is bigger than 1, but remember this is a negative number. So all the step is doing is it's basically telling you to round off any extra decimals, but not round in the sense of our traditional rounding rules, where if it's 0.5 or higher, we round up. If it's 0.5 or lower, we round down. It's basically taking the integer that is less than or equal to that number that you're dealing with. Okay, so you first have to understand that concept. When we graph them, the easiest way to graph them is to pick some points in between a certain set of integers. So like I picked numbers that were between 0 and 1. I picked numbers then that were between 0 or 1 and 2, and then also between 2 and 3. So I picked some decimals. So let's go through and actually figure out what is the step of 0. Well, the greatest integer that is less than or equal to 0 is 0. So when it's a whole number already, you don't have to worry about it. So the step of 1 would be 1. The step of 2 would be 2. And finally the step of 3 would be 3. But now when we talk about taking the step of a decimal, so if I ask you to take the step of 0.3, round it basically down to a 0. That's what the step is saying. So I round it down to 0. The step of 0.5 would be 0, and the step of 0.7 would also be 0. So basically, at these x values between 0 to 1, my graph is going to stay at 0 until I get to 1, where it bounces up to the next integer. And what's going to happen for 1.3, the step of 1.3 is 1. The step of 1.5 is 1. The step of 1.7 is 1. And finally, the step of 2, you know, if you get rid of the decimal, you're still at 2, you're still at 2, you're still at 2. So I'm asking you to make the table because I think it really clearly helps define what the graph is going to look like. So let's start plotting points. 0, 0. 0.30 would be right about here. 0.50 would be right about here. 0.70 would be right about here. And then at 1, my graph jumps up to here, because it's 1, 1. So any number, any decimal that I can think of between 0 and 1, the step of it would be 0. So all of these values up until I got to 1. So I don't want to draw my line all the way over to 1, so I put an open circle there to show that at 1 it doesn't exist there, but it exists back up here. And this is where the step concept comes into. It's going to look like a set of stairs or a set of steps. So then at 1, I'm at 1. At 1.3, which is right about here, I'm at 1. At 1.5, at 1.7. And I stay on this line until I get to the next integer, where I bump up 1. And then it stays here at 2.3, at 2.5, at 2.7, and then when I get to a x value of 3, it bumps up here to a y value of 3. And so that's what my graph is going to look like. Now my table only shows these 3 parts of it, but the graph is more so than just this. So the pattern is going to continue. So if my graph was bigger, it'd be that. The next one would come up and go like this, or it would also go this this way as well, where I could put a dot here, and it would stay at this line until I got to the next integer. Dot here, and it would stay at this line until I get an open circle there. Dot here, and it would stay at this line until I get there. So this is the step idea. It looks like we're climbing a set of stairs. One thing I want to point out to you, when you type this into your calculator, and I'll show you how to do that in a minute, but when you type it in the calculator, it's going to look like, and don't draw this on your graph, it's going to look like this. Because your calculator is set up to graph it continuously, that's not really what the graph looks like. It's open and closed circles, just a portion of it, then it jumps up here. So this portion, I'm going to go through and erase it. This portion right here, this vertical portion, does not exist. Whoops, I didn't want to erase all of that. I'm erasing everything. Okay, so what portion does not exist would be this vertical portion. So this red that I'm taking off of there, that's why your graphing calculator is going to show it to you, but understand that these are just there to make the graph be a continuous graph when the calculator graphs it. Okay, so understand that your graph is really just going to be these blue lines. Closed circle at one end, open circle at the other, and then it jumps up to the next integer, closed circle, open circle, jumps up to the next integer, closed circle, open circle. So what I want you to do now is I want you to take a look at the your graphing calculator, and the graphing calculator that I have will not do a step function. Okay, so I can't show you this myself, and if you've got questions on it, please ask in class tomorrow. But I want you to insert into your calculator, into the y equals int of x, and you can find int under the math function of your calculator. So you go to math, then hit number, and then hit int, and then close the parenthesis around the x, and you're going to get the graph that would be the red line that I was showing you. So take a second to put this into your graphing calculator. If you have questions on how to use the graphing calculator, see me in class tomorrow. But that's what your step function will look like. It'll look like a set of steps or a set of stairs. The last concept in the notes today that I want to talk about is called a piecewise function. It's a piecewise function because it's going to be 2 different parts of the graph. So you're really going to have one part of the graph that will exist at 2x plus 3, and another part of the graph that will exist for the equation negative x plus 4. The other part that's important is going to be the domain that you're given. Okay, so this graph will only exist at x values that are less than 1 or equal to 1. So this one is going to be the 2x plus 3. I'll change colors to blue, and this will be the negative x plus 4. So if the x values that work are those that are less than or equal to 1, then I want to start my graph at 1 and pick values that are less than that. So the next smallest x value would be 0, -1, -2, -3. Probably should have done that in red to keep my color scheme the same. Let me change that. On the other hand, this portion of the graph exists at x values that are greater than 1. So I'm going to start it at 1, and this is going to be important. Both of my t-tables will start at whatever these numbers are. But since it's not equal to 1, what I want to do is put a not equal sign here, so I know when I graph this, I'm going to have to make it an open circle. Since it's equal to 1 here, I'm going to use a closed circle on my graph. So remember that these inequality signs will mean open versus closed circles depending on whether or not they're equal or not. So I'm going to use a 1 in the t-table, and then the values that are bigger than 1 would be 2, 3, 4, and 5. And I'm going to get 2 portions of the graph. So let's take the time to input these values. So if I put a 1 into here, I'm going to end up getting a 5, a 3, a 1, a -1, a -3. If I put these numbers into the second equation, I would get 3, 2, 1, 0, and -1. So if I go to plot these now, let's plot these points. 1, 5. I'm putting a closed circle because it can be equal to 0, 3, -1, 1, -2, -1, and -3, -3. So here's what I need to do. Now normally what we do is we connect our points and then we extend it on both sides. Well, since my graph, these values can only work for x values that are less than 1, my graph cannot exist on the right side of this line. So I only extend this side of it. So that's what this portion of the graph will look like. So I'm only graphing the portion of this line that is less than or equal to 1. Now the blue one will look like this if I plot these points. 1, 3, it's not equal to there, so at 1, 3 I want to put an open circle here, not a closed circle, because the graph does not exist there. Then I put 2, 2, 3, 1, 4, 0, I could keep going, but I really didn't give you enough space to keep going, but if you extend that out, it's going to look like this. And since this graph cannot be less than 1, I can't have it exist to the left side of this line that I put on here. So this graph is only going to get extended out this way. Draw that a little bit better. The biggest mistake that students will make with these graphs, and I shouldn't have really had this go all the way through here. That should be an open circle and my graph should start there. It doesn't go in the middle of that. The biggest mistake that students will make here is you will graph the entire graph. You will extend this side out and you will extend that side out. A piecewise function says that you can only graph a certain portion of this equation, and you can only graph a certain portion of this equation. The other thing that you will do is you will not put a 1 in here and you'll say, oh, x values that are greater than 1, it would be 2. But isn't a 1.5, doesn't that work? At 1.5 my graph would be right here. A lot of times what students will do is they will only graph it like this, they won't include that part. And then that would be wrong because the graph does exist right here at 1.5. At 1.5 it's going to be 2 point something, it's going to be right there. It just doesn't exist right there at an x value of 1. So you have to include the 1 here, but make sure you put an open circle so that you can say 1.1 works, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8 until I get all the way over to an x value of 2. And so again, it's a piecewise function because you're graphing 2 different graphs on one axis and you're only using certain pieces of it, in this case certain x values, those that are either less than 1 or greater than 1 for this example.